What if I told you that the secret to building these incredibly powerful AI models wasn't actually about bigger algorithms or faster computers? Today, we're going to pull back the curtain on the one factor that is quietly driving every major AI breakthrough. And believe me, it's hiding in plain sight.
So, what is the secret sauce here? Is it really just about building bigger, more complex models? Piling on more and more layers? Or is there something else going on? Something more fundamental that separates the pretty good AI from the truly groundbreaking stuff?
Well, to answer that, first things first, we need to take a closer look at a huge misconception that's been around for a while, what I like to call the AI model myth. For the longest time, the story of AI progress was all about being model-centric. The whole idea was pretty simple. If you want a better AI, you need a bigger model, a fancier algorithm, and basically a warehouse full of computers. But now, the script has totally flipped. The focus is shifting, and it's shifting fast, to a data-centric approach. This is where the real breakthroughs are coming from, engineering better, smarter, higher quality data. And look, this isn't just some small tweak in thinking. It is a full-blown revolution happening right now, and we've got some incredible evidence to show you just how big a deal this is. Let's just rewind the clock to 2020 for a second. OpenAI drops GPT-3 on the world, and it is a model so powerful it just completely reshapes the entire landscape. It was, without a doubt, a monumental achievement for that model-centric way of thinking. Now, on the official paper for this world-changing model, guess how many people were credited for the absolutely massive job of collecting and filtering all that data? Just two. Only two people. Okay, now fast forward just 3 years to GPT-4. The number of people credited for data processes, so working on the data, it explodes to over 80. That right there brilliantly shows you the shift in mindset. The secret weapon wasn't just a bigger model, it was a huge dedicated army of people engineering the data. And this isn't just some fringe idea. AI pioneer Andrew Ng summed it up perfectly. He pointed out that the whole game is fundamentally changed. We've gone from giving teams the same data set and asking them to find the best model, to giving them the same model and challenging them to find the best data set. So if data is the new king, how do you actually engineer a data set that's fit for a king? Let's break down the art and science of what's called data curation. It all comes down to this idea of data curation. And honestly, the best way to think about it is like cooking a gourmet meal. Your data, that's your ingredients. And data curation is the art of being a chef, picking the absolute best ingredients and balancing them perfectly to create something amazing. And that whole process really rests on 3 core pillars. First, you've got quality. Are your ingredients fresh and clean? Or are they, spoiled and totally irrelevant? Second is coverage. Do you have the right mix of flavors to make a balanced dish, or is it all just salt? And finally, quantity. Pretty simple. How much food do you actually need to cook? Now let's double click on quality for a second, because it's about way more than just being clean. Each one of these traits is absolutely critical. For example, if your data isn't consistent, your AI is learning confusing, contradictory rules. If it's not unique enough, if it's full of duplicates, it can develop massive blind spots. Getting every single one of these points right is completely non-negotiable. Okay, now check this out. This table shows the data mix for Meta's Llama 3, and it gives us a fascinating look at data coverage in action. Just notice the huge emphasis they put on math, reasoning, and code, especially in that early pre-training phase. It makes up a massive chunk of the dataset. So why? Well, it's because the top AI labs have discovered this amazing secret. Training a model on the logical, structured nature of high-quality code and math doesn't just make it better at coding and math. It fundamentally improves its overall ability to reason about everything. And what about quantity? This chart from OpenAI is really interesting. If you look on the left with a pretty small data set, a more advanced base model gives you a huge advantage. But now look what happens on the right when you have a massive data set. We're talking over 500,000 examples. The performance of all the different models starts to even out. So the takeaway here is huge. More high-quality data can sometimes be way more important than just having a fancier base model. But what happens when you hit a wall? When that perfect data that you need for your model, it just doesn't exist out in the wild? Well, you don't find it, you make it. This is where we get into the really bleeding edge stuff. Data augmentation, that's pretty simple. You take real data and you just tweak it a little, like flipping a photo of a cat.
But data synthesis, that is next level. That's where you generate completely new, totally artificial data from scratch that has all the right properties of real data. And this is an absolute game changer.
So why on earth would you use synthetic data? Well, the reasons are incredibly powerful. You can generate data at a scale that's just impossible to collect from the real world. You can create these perfect examples to train for those rare, weird edge cases. Think about a self-driving car trying to navigate a freak snowstorm. And you can do all of this while completely sidestepping privacy concerns because no real user data is ever involved.
And if you want to see a masterclass in this, look no further than the pipeline the Llama 3 team used to create its coding data. I mean, they didn't just ask an AI to write some code, no way. They had it generate problems, then solutions, then generate tests to check its own work. If the code failed the test, it would revise it. Then it would translate that perfect code into other languages and even write the documentation for it. It's this incredible, self-correcting data factory. But, and you knew there was a but coming, this incredible power doesn't come without risks. This new frontier presents a really serious dilemma for anyone building AI.
On one hand, the promise is obvious. You get scale, you get coverage for edge cases, privacy, maybe even higher quality. But the peril is just as real. The AI can create data that only looks right on the surface. It can amplify biases that are already there, and it creates a huge risk of something that researchers are getting really worried about called model collapse.
So, what exactly is model collapse? Well, it's what can happen when AI models are trained on too much data that was also generated by an AI. They start to forget. They forget the weird, the rare, the improbable parts of reality, and they become this blurry, averaged out version of themselves. They get stuck in a feedback loop of their own creation, and their performance can actually degrade permanently.
In the end, it all comes back to one simple truth. As we push deeper into this new era, yeah, the AI models are going to keep getting better, but the ultimate limit on how smart they can be will always be the data we choose to teach them with. The real secret to powerful AI isn't just in the code, it's in the curriculum. Thanks for joining us.